Solving quadratic equations by completing the square. So, first one we have is actually quite straightforward. What we're going to do is square root both sides. So over here we just get x plus 3. And on this side we get positive or negative root 7. Think about the fact that root 7 multiplied by root 7 is equal to 7, but negative root 7 multiplied by negative root 7 would also be equal to 7. Then all we need to do is take the 3 to the other side, and we'll have negative 3 plus or minus the square root of 7, and that's what's known as an exact answer. We can, of course, get a calculated answer. All we need to do is do negative 3, add the square root of 7, and we get a decimal answer like so, and then we can just go back and edit that so that we have minus root 7, and we'll get a decimal answer for that. But let's stick with exact solutions for now. So looking at this second example, we have x minus 2 all squared would be equal to 8 if we just add 8 to both sides of the equation. Now we can square root. We'll have x minus 2 is equal to plus or minus root 8. Now remember that root 8 is root of 4 times 2, so that's root 4 root 2, giving us 2 root 2. So x minus 2 is going to be plus or minus 2 root 2, and you should simplify the third if you can, and then the exact solution would be 2 plus or minus 2 root 2. Just add the 2 to both sides. So now we have a situation where we need to complete the square first. Now I can do this fairly quickly because you'll know how to complete the square by this stage. So squared brackets with x and plus 4, and that would give me a 16 that I don't want, and then I've got the negative 3 which I haven't used yet. So that gives me x plus 4 all squared, take away 19, is equal to 0. So add 19 to both sides, x plus 4 all squared equals 19. Square root x plus 4 is going to be plus or minus the square root of 19, and then subtract 4 from both sides. So we have negative 4 plus or minus the square root of 19. So those are our two solutions. Negative 4 add root 19, and negative 4 take away root 19. Now for this one here, I need to factorize the first two terms, so that's 3, and then we'll have x squared minus 2x. When I say factorize, I mean just take out the common numerical factor. You need to leave the x's inside here. And take away 2. And then we want to complete the square inside here. So that's going to be 3 x minus 1 all squared. That will give me the x squared minus 2x, but it also gives me a 1 that I don't want. So I just take it off. Expand out, and we've got 3 x plus 1 all squared. Take away 3, take away 2 equals 0. Let's tidy. 3 x plus 1 all squared, take away 5 equals 0. So 3 x plus 1 all squared equals 5. Then x plus 1 all squared would be 5 over 3. Square root gives us x plus 1 is equal to plus or minus the square root of 5 thirds. And so our solutions are x is -1 plus or minus the square root. Let's make sure that square root goes all the way around. The square root of 5/3. Now, we've seen this example previously when we were factorising. Let's see if we can get the same result when completing the square. So multiply both sides by x to get rid of the fraction. So 12 over x, multiply that by x, and those would cancel. So we've got x squared, add 4x is equal to 12, and then subtract 12 from both sides. X squared, add 4x, take away 12 is equal to 0. Now complete the square. So this would give us x plus 2 all squared. That's going to give us x squared plus 4x, but it also gives us a 4 that we don't want. And then don't forget the -12. And so we have x plus 2 all squared, take away 16 is equal to 0. So x plus 2 all squared is equal to 16. X plus 2 then would be plus or minus the square root of 16, and we know the square root of 16 is 4. So then I've got x is equal to -2 plus or minus 4. So that's going to be -2 add 4, or -2 take away 4. Well, -2 add 4 gives us 2, and -2 take 4 gives -6. And those are the same solutions that we got when we did this by factorising.